All right, everybody, we're going to continue on with our geometry review, such as it is. And the last two questions we have involve circles. So let's start with this first one here. So in the figure above, if the circle with center A has an area, oh gosh, that was awful. Try that again. Has an area of 32. That was even worse. I don't even know why I bothered to try to correct things. It just comes out worse when I just should have let it go the first time. Anyway, okay. All right. Has an area of 32 pi. What is the area with the circle of center B? Well, okay. We know that the key idea is that to find the area of a circle, be all fancy there, area sub C, that is equal to, the formula is pi times the radius squared. So once we know what the radius is, then we basically have all the magic that we need for any circle problem. Okay, so let's look at this. We know that the circle with center A has an area. We need to find the area of center B. Well, in order to do that, we need to know what the radius is for B. But the only numeric information we're given is with A, so let's start there for a moment. So if we know that the area of, I'm going to put area of the A circle is equal to 32 pi, we know that that's equal to pi r squared, right? Therefore, we can figure what the radius of the A circle is. Well, let's look at this equation here. We can cancel off the pi's on both sides, and we end up with 32 is the same thing as r squared. I could take the square root of both sides, and that gets me to something like root 32 is equal to the radius. Okay, well, we're probably going to have to simplify this a little bit, so let's just go ahead and do so. This is actually a good review. To simplify a radical here, remember we do the factor tree method. We think about, okay, what are the numbers that can multiply out to make 32, or root 32 technically? Well, root 2 and say root 16, that works, and then root 16 is the same thing as root 4 times root 4. Let's pause here just for a moment. What we did here in the green is we said that root 32 is the same thing as root 2 times root 4 times root 4. And double check now. I mean, you should be able to, like 2 times 4 is 8, and 8 times 4 is 32. We get right back to root 32. But because we have root 4 and root 4, hopefully you remember this, whenever you multiply a root times itself, the root sign just cancels off and leaving you just with that thing. So root 4 times root 4 is just 4. So really the whole thing boils down to root 32 is the same thing as 4 times root 2. Pause the video if that confused you, but that's kind of an important skill set to have on the SAT, and just in math, and high school math in general. But that would be the simplified form of root 32. So what we figured out, going back to the pink, is that the radius of the A circle is equal to 4 times root 2. Okay, but we're not interested in the A circle. We want to know what's the area of the B one. Well, we can't figure out the area of the B one unless we know the radius, but look at this. The radius of A goes all the way across here, right? And that's going to be equal to 4 root 2, which we just figured out. Well, if you think about it visually, that's just the diameter of B. And we know that the diameter of B is just double the radius. So to find the radius of B, we just need to cut this number right here in half. Now that would be, so say radius of the B circle, oh, that was the sorriest looking B you've ever seen in my life. Okay, the radius of the B circle is just going to be 4 root 2 divided by 2, which is just 2 root 2. Okay? I know, this is intense. We're hanging there. We're almost done. We figured out the radius for B is 2 root 2. And now they wanted to know what was the area of that circle. Well, we can take that 2 root 2 for the radius and plug it into our equation, right? The equation, the area of circle B is just going to be pi r squared. And we know what r is. The radius is 2 root 2. So it really just comes down to it's pi times 2 root 2 times 2 root 2. And remember what we talked about over here. If we have the same root multiplied by itself, the root sign just disappears and you're just left with that number. So we have a root 2 and a root 2. It's going to cancel off and just become 2. So we end up with we end up with pi times 2 times, so this 2 right here, this 2 right there, and then these roots multiplied together also just become 2. So it's just pi times 2 times 2 times 2, which is just the same thing as 8 pi. And there we go. And there's our answer. Okay? Hopefully that wasn't too confusing. All right, last problem. This one here. It says in the figure above, this one looks scary, but it hopefully is not too bad. In the figure above, rectangle WXYZ is inscribed inside the circle. If XY is equal to 12, I'll just pop that. I strongly recommend you do this on the SATs. Just mark things up as you go. So if that's equal to 12, and the radius of the circle, so this portion right here is 6.5, what's the area of the rectangle? Well, okay, so let's just think about this. In order to find the area of a rectangle, we need to know base times height, right? Looks like they tell us the base. So let me just sketch a little triangle out right here, just for a moment. Okay. So then look at this. We know the base. Let's put it in this color. The base here is 12, but we don't know the height. Once we know that, then we can just multiply those two things together, and we're done. So that's our goal. We got to figure out what is this length right here, or this length right here. They're both the same thing. Well, notice something. Notice we have a triangle inside. I'm going to sketch this out. Okay, and it's going to be a horrible sketch, but just bear with me here. So let's take that triangle just for a moment. Oh gosh. All right. Well, just I'm sorry. I'm sorry. But that's actually good for you. It's it's teaching you to think abstractly, because the diagrams that I'm drawing are just not going to be helping. Okay. But all right. So here. But notice just that pink triangle that I drew here is just supposed to be this thing right here. Okay. That's what I just lifted off. So let's plug in some things here. We know that this length right here has to be 12. This length we do not know, right? And that corresponds to this missing side here. But we do know the hypotenuse, because they said the radius, so from the center of the circle to y, or to w, is 6.5. So that means we've got 6.5 is that length right there, and 6.5 is that length right there, right? To go from O to the end here is 6.5. To go from O to this end here is 6.5. So the whole thing, the hypotenuse, is just going to be 6.5 plus 6.5, which is, check me if I'm wrong, is 13. Okay, so now think about this. We've got a right triangle, and we know it is a right triangle because they said this was a rectangle inside. We have a right triangle where we know 2 of the side lengths, and we need to know the missing side here. Da-dum, 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 da-dum. I think you all know what I'm going to say next. Pythagorean theorem! Woo-hoo! Okay, sorry. Little bit sorry. Not that sorry. Okay, let's see. How do we set this up? So that is just going to be the 2 smaller sides squared is equal to the hypotenuse squared. Let's just plug in what we know. Let's just arbitrarily say that's A, this is B, and this is C, that's the hypotenuse. So we're going to have A squared plus that side squared is equal to C squared. Okay, and that gets us to A squared plus, check me on the calculator, but I'm pretty sure I have this right, is 144 is equal to 169. We subtract 144 from both sides. So I don't know why I'm singing a little song here. It's hanging around with a 4-year-old all day. It's what does it to you. It's like everything is just do 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 all day long. It sticks in your mind. Okay, here we go. A squared. Let's see. Okay, so that cancels off, right? And so we have 169 minus 144. That should be 25. Check me again. And then we take the square root of both sides, and that gets us to A is equal to 5. Right? So this side right here, this side of the triangle, is equal to 5. But remember that matched up. Well, I should have done a different color. Not that it matters, but here we go. And that matched up with this side right here on the rectangle. That's also 5. So we finally got our answer, right? We found the piece that we needed. We needed this side length is 5 and 12, and then the question was, what is the area? So we just multiply those two things together. It's going to be 5 times 12 is equal to 60. And we are done. Now, that problem was a good one. I want you to definitely review over this if this confused you, because this hit you on a couple of different notes. It quizzed you on your knowledge of rectangles, area, triangles, Pythagorean theorem, and circles involving radiuses. So it was like a lot of geometry was going on in that problem. Make sure that you understand that. If you're confused over anything, you know how to reach me, but that should do it for now. All right, I'll leave you in peace.